So now we're moving into topic 2, visual perception. So visual perception is all about, or in the name, visual perception, how we perceive visual stimuli. And there's two main overviews, two main overarching parts of this. Sensation is like the first 3 steps. So sensation involves reception, transduction, and transmission. And then our second 3 are part of the step that we call perception, which is that selection, organization, and interpretation. So to give a bit of background knowledge for this, like when we see something, when we see anything around us, the image on our retina is actually upside down, back to front, it's blurry and it's patchy. So these 6 stages cover from like the time that our eyes are actually collecting the sensory information to when our brain actually interprets what we see. So sensation, our first one, sensation being kind of that overarching first 3, when we're like sensation, we're receiving the sensory information, and then perception is kind of the second 3, when we're perceiving it, we're making sense of it. So sensation, the first 3 parts. The first one is reception. So light energy is collected by our eyes. It enters through the cornea, it travels through the pupil, and is focused on the retina at the back of our eyes. So this light energy, and light energy is like the visual part of the electromagnetic spectrum, and it must be within like the visible light spectrum, which is around 360 to 760 nanometers, and that's for it to be perceived by the average human. So reception is all about light energy being collected by the eyes. That's the basic overview of it. Our second step, transduction, is where light energy is received by the receptive fields at the back of the eye in the retina. So the receptive fields are groups of photoreceptors, which again are cells on the back of the retina that are sensitive to and they detect light. We have 2 types of photodetectors that are working. We have rods and we have cones. So rods are particularly sensitive to like black and white, and we rely on them more in dim light. They're very light sensitive and they're responsible for like a lot of our like peripheral vision, and they're concentrated more at the edge of the retinas, and they have like very low visual acuity, so which is kind of like low detail and sharpness, which is contrasted with our cones, our second type of photoreceptor cells, which provide clear vision, like they're all about color vision. They work really well in the bright light, and they're concentrated in the middle of the retina. They're responsible for visual details and require high levels of light to enable a response. So in this step of transduction, the photoreceptors, which are our rods and our cones, again, rods, black and white, cones, color vision. That's another good way to think about it. Cones, color, whereas the rods are the black and white vision. What they actually do is they convert this light energy, this incoming like stimulus information, to electrochemical nerve impulses that can be passed through the optic nerve to the brain in our third step, which is transmission. So it's about taking this light energy and putting it into an electrochemical message that we can actually send to the brain. And transmission, the third step, is when this electrochemical message is passed along the optic nerve to the visual cortex, so the brain can actually start to make sense of what we see. Because without our brain, our eyes would be useless, and the visual cortex is in the occipital lobes of the brain, again up the back of the brain. So that's another way to help remember what the occipital lobe is responsible for, visual perception. So those first 3 steps are sensation, so when we're receiving that sensory information from the environment. Like the light energy entering our eyes, being focused on the retina up the back, being converted to that electrochemical message, and then that message is sent along the optic nerve to the brain. And then this is where we enter perception, the next 3 steps, when we start to make sense of what we see. Step number 4 of 6, but like the first part of perception, is called selection. So this is getting into the idea that we actually can't pay attention to like the millions of stimuli that we receive at the same time. So our brain actually picks what we pay attention to, and the optic nerve actually has a role in it as well. So think like selective attention. Unconsciously, we're choosing what to pay attention to. So this is actually done by feature detectors in the optic nerve. and visual cortex, which break up the images into their features. So for example, like line length to help us decide what are we actually going to pay attention to. A really practical way to think about it is we're actually never paying attention to everything that we're looking at once. So for example, currently I'm focused on like my laptop screen and my camera as I'm like delivering this presentation, whereas behind my laptop, I actually have my whole bookcase, but I'm not actually actively paying attention to any of the titles and words because my brain actually can't actively process all of this information all at once. So my feature detectors are helping me like decide and undertake selection. What should I actually be processing and taking notice of? Which brings us to organization, our fifth step, where the visual cortex recognizes the information and it organizes it into a meaningful whole so that we can actually make sense of it using like visual perception principles. Some of these are like our perceptual constancies, Gestalt principles, depth cues, which we'll look at later. So these visual perception principles help us guide the reassembly of the image. So we're kind of putting the image together in our mind, which brings us to interpretation, the sixth step, which is where we actually make sense of it and give it meaning. So we can the image is kind of put together in organization, like it's being organized, but it's not until our sixth step, interpretation, where it's actually kind of given meaning to, like we make sense of it. And how it does this is it's simultaneously sent to the temporal lobe to identify the object by comparing it to information we already have in memory. So for example, if I see the face of somebody I'm familiar with, that information is entering my eyes, being sent to my brain, and then my occipital lobe is sending it to my temporal lobe and comparing it to what I already have in memory. Like, oh, that's Michelle, because I'm comparing it to information I already have in memory, so I can recognize it. Even something as simple as an apple, I can recognize an apple because I'm comparing it to pre-existing memory. And simultaneously, that information is also sent to the parietal lobe to judge where the object is in relation to our visual field and ourself. So again, parietal lobe, we're thinking like spatial awareness kind of thing. So that makes sense because we send the information to the parietal lobe to judge where it is, like in distance wise, like is it close, is it far? And again, we use depth cues and all sorts of things to help us with that. And then images are also given meaning based off our perceptual set, which we'll be having a look at shortly. So that's kind of things like our past experiences, like our motivation, our values, and our context. So we're kind of getting into the idea that there are so many different things that influence how we see what we see. So there's this like biological process of we're actually getting the image that we see into our brain so that we can actually process it. But then there's also all of these other things that are influencing what we see, which we're going to be having a look at now. We're going to be looking at like some of the biological, psychological, and like social and cultural impacts or influences on visual perception, which is getting into the idea that there are quite a lot of things that influence our visual perception. So things that influence how we see what we see. For example, even just like a really random example, when most people look at a dog, like that might bring them like really warm and happy feelings because they might think it's a really cute dog. But somebody that has the past experience of being attacked by a dog might go like, oh my gosh, and enter like absolute panic mode, which is a completely appropriate response based off their past experience. But you can kind of see how our visual perception may differ based off a whole lot of different things.